So hello, everybody. My name's Andy Rivenes. I'm a product manager for database and memory. We also have a guest. I don't know, Jesse, do you want to turn your video on?
Oh, yeah, I can.
We also have Jesse Kamp, who's an architect and one of the first, or basically has been a developer with database and memory since the very beginning. Yeah, there it is. And so hopefully we can answer all of your questions. What I wanted to do is I wanted to talk about the duplicate feature or the duplicate clause, depending on how you want to talk about it. I did put a blog post out yesterday, or actually I think I posted it, started on Friday. Sometimes it takes our blog system a while to get that going, to go along with this, but we'll also have this recorded. I would be remiss if I didn't point out our other sessions and also some resources available if you're interested in finding out more information. If you have questions, you're muted, but go ahead and type them in the chat window and we'll try to answer those questions for you, whether they're regarding the duplicate feature that we're going to talk about for a few minutes or any other database and memory type questions. More than happy to talk about that, since if you hadn't heard, 21C for the cloud has been announced. If you want to check Twitter, I retweeted one of Maria's posts on that. And so that documentation is available, and there are some new database and memory features as well. So if you're interested in what's coming in 21C, I would encourage you to go take a look at that. And with that, we'll dispense with this. I'm going to leave this for now, and I think in this mode, it's easier to jump around, I think, with both in the presentation, then we're going to do a couple just kind of brief demos to show you I finally have access to an Exadata system. It's only 2-node. We'll talk a little bit about how that affects the duplicate feature, but so we'll kind of try to show you how this actually works in action. And so with that, that's our introductions. My email's there if you do have questions after the fact. You can follow me on Twitter. And then I'll have the blog resources page. We'll talk a little bit about that at the end, where if you want to find out more information about database and memory. So with that, I think that's everything. You have anything to add, Jesse? I'll ping you every once in a while unless you...
Yeah,
okay, well, that's fine. So let's talk a little bit about the duplicate clause feature that's in memory, part of database and memory. It is associated with RAC because it's really about distribution of data and the way to get essentially fault tolerance. And so that's kind of what this picture talks about. It is only available, though, on engineered systems. So I know for some people that's who don't run Exadata, essentially Exadata is kind of really the main engineered system platform that folks will target for database and memory. And so if you're on commodity hardware, this option or this feature won't work. It's really for Exadata only, and so get that out of the way.
Yeah. Also,
highlight as we talk about this, though, is that this is, and I had to actually change this slide. So I wanted to make sure that I emphasized that what we're talking about is at the IMCU level, even though I'll show you the syntax, and the syntax is at the segment or object level. I kind of use the terms interchangeably, but they're not really interchangeable, especially when we talk about partitioning. But that this isn't the actual object itself per se as it is, but it's because of the IMCU. And I threw in another slide to kind of talk about, review that. And actually, since I got on the subject, maybe we'll just do it now. So as a review, and we've talked about this in the past, when an object is populated, either a table, partition, subpartition, or materialized view, when you enable that for in memory, we're going to basically populate that segment with one, depending on how large it is, one or more IMCUs. And so that segment will be made up of one or more IMCUs in a column store allocated out of the 1 meg pool. And then each IMCU will have associated with an SMU, which isn't really all that important for our discussion, but worth noting. And each of those SMUs will be populated out of the 64K pool. So when we talk about duplicate, which I'll go back to the slide in a second, we're really talking about these individual IMCUs that make up the object as it's populated in the column store. So I realized when I was putting this together that I really needed to make sure I emphasize that, because it'll make a little bit more sense when we look at some of the examples. And we'll go back to this. So there's actually two flavors of the duplicate option. If you say alter table in memory duplicate, then what we're going to do is we're going to actually mirror those IMCUs, or we're going to create two copies of each of those IMCUs and populate it in the column store. So in the example I have here, if we have a 4-node rack system, then what's going to happen is a second copy of each IMCU is going to be distributed across that 4-node rack cluster for the database. And so what this allows then is to say this node, I guess I can do that. So that node were to go down, then the IMCUs that were in, notice the arrows are still there, the IMCUs that were in that node will be actually populated or mirrored. There'll still be a copy in one of the other surviving rack nodes, and that's the fault tolerance part. So now if you're able to connect, hopefully through services, to a surviving node, you can run your application when it accesses the in-memory columnar data. You won't see any performance degradation. Whereas if you hadn't duplicated that data, then you would actually see a performance degradation, because part of that data would then have to come from the row store. And we've talked about how if data is not populated in the column store for whatever reason, perhaps it's in the process of being populated, perhaps you ran out of space, you won't get an error, but we'll access that data then from the row store. So actually, I guess I could undo my, there we go. Man, that's high tech there, huh? But the bottom line here is that that's what the duplicate option is really all about, is fault tolerance, such that if one node were to go down, you would still be able to maintain the in-memory columnar performance for the queries that are accessing data in memory. Did I get that right, Jesse?
Yeah. That sounds about right.
Okay. And then there's actually a second or another option to the duplicate clause that allows you to do a duplicate all. And so if you say, and I'd be remiss if I didn't highlight the fact that not only is it IMC related, but it's on a per table, partition, subpartition, or materialized view basis. So it's when you do the alter table in memory, depending on whether you do modify partition or just on an alter table. So you don't have to duplicate all objects, just perhaps the most important ones to maintain performance, in-memory speed performance for your critical queries. Sorry, a little tongue twister there. But there's also the all options. So you can specify alter table in memory, and I'll show you the syntax in a second. I have some slides for that. But duplicate all, and what that does then is it duplicates the IMCUs for the object that you specify as duplicate all to all of the nodes. So whether you have 4 nodes, more than 4 nodes, maybe you only have 2 nodes, we'll duplicate the IMCUs, so that's the red guy there, across all of the nodes. And and there's a, so that's the ultimate fault tolerance. So you could then survive a multi-node failure in rack if, assuming your application can handle that. But it also gives you some advantages, and I'll talk about that a little bit and show you a little bit of an example of being able to enhance performance, because some of the, one of the things you can do is with joins, you could then have joins take place entirely within the node. I should review the fact that if you don't have duplicate on, either in this example or this one, and you've distributed the data on rack across the column stores, then we use parallel query to access that data. And so if you use duplicate all, it is possible to avoid having to invoke parallel query to join objects that are co-located within the same column store. And I'll talk a little bit about that as well. So I think those are all of the ideas that I wanted to cover about what duplicate is and how it works within database and memory. I was going to show you some of the syntax, and then I'm going to flip over, and hopefully my screen will still be there, and if not, we'll reconnect to show you some examples. And then any questions. If you have any questions, please feel free to type into the chat window, and we'll be more than happy to answer those. And then we can open it up to discussion on any other in-memory topics as well. So back to the topic at hand. Alter table line order in memory would be the kind of the standard line order table, being our SSV fact table that I use for all of my examples. Basically, would be the default. Then if you're on Exadata or an engineered system, supercluster for folks that have it, and ODA, I don't remember off the top of my head, I think I have it somewhere, whether ODA is supported. I think it is if you have an InfiniBand interconnect. Again, there's in the documentation, you can get any limitations. You can say alter table line order in memory and then duplicate, which will give you this picture where we're just going to mirror the IMCUs. And then we also have the syntax for duplicate all, which then gives you that picture where we're going to mirror the IMCUs across all nodes involved. And again, to stress that this is at the object level, so you can pick and choose not only what objects you populate in memory, but also what objects you decide to duplicate versus maybe just normal distribution across the column store. Because the other thing I guess I should mention, which is maybe somewhat obvious, but maybe not, is that this will take up more memory. So by mirroring the IMCUs, you're going to, each of the objects you decide to mirror is going to, duplicate is going to take up more memory in the column store, because we're going to duplicate each of the IMCUs. So on a 4-node rack, we're going to use we're going to make copies, so you're going to have less space for actual data than if you just distributed it and didn't do duplicate. And with the duplicate all option, you're really only going to have the total amount of space on the rack cluster that you would have for a single column store if you duplicate all of the data, because it's literally all copied, or there's a copy of it in each of the nodes. So it does take additional memory out of the column store, and so you have to plan for that as well. With that, I'm going to stop. I made the slides just in case we have a disaster, which I don't think we'll have. So what I'm going to do is I turn top on. What I think I'll do is I'll just save that or put that down. Maybe make this a little bit bigger so everybody can see that. I put top on so I wouldn't get logged out, because this system logs me out very quickly. And let's go ahead and quit out of that. And what I have is our kind of my normal hands-on lab scripts, so I don't have to do too much typing. But, and I think I forgot to bring up my cheat sheet, which I should do. So I had some specific things I wanted to cover. Let's see, where did I stick that? Demo. Nice name. So I wanted to do a few of these commands without having to stumble over the typing of them. So I'll stick that over there. And what we have is, I have a 19.8 instance running on Exadata. So it's actually only a 2-node cluster. You would think those of us that work at Oracle would get resources, anything we want, and that's not true. So what I have access to, though, which is actually surprising, because it took me it's taken me a long time to get access to actual Exadata system to run some of these demonstrations on. But it's a 2-node Exadata system, and I've done an alter table line order, just in memory, standard distribution across the 2 nodes. Notice that it says no duplicate. I keep messing around. And the query I'm running is off of GVI, can't even speak, GV$ IM segments. And so there's a a whole boatload of attributes, and the one that we care about is in-memory duplicate, which is where this is coming. So you can determine the objects that you've marked for duplication and objects you haven't. And so we're taking the auto distribution, which in this case for just a table is going to be a distribution by row ID. And so what we see here is we've got a total amount on disk size, and then in memory, it's been distributed across the two nodes. And notice it says bytes not populated. And that's kind of how that works we talked about this in past AskTOM Office Hours sessions. That's how that works in rack when you do normal distribution, because not all of the object, in this case line order, is populated on node 1, because also some of that object is populated in node 2. So the bytes not populated reflects what's been essentially populated or in the other node, or perhaps not fully populated. In this case, it has been fully populated. So not to go into too much detail, but that's what it would look like with just normal distribution. Maybe you're on commodity hardware, or maybe you have certain objects that you don't need to duplicate. And so if we run, and what I did is I decided to go ahead and run the queries now in the interest of not having to repopulate things. So I'll show you duplicate or duplicate all in a second. But if you're in a normal rack environment with row ID distribution, we have to use parallel query in order to access both nodes, because I'm on one of the nodes connected with SQL+, and I can't access the data on the other node unless I use parallel query. That's kind of the architecture both of Oracle and database and memory. Again, we talked about that. So let me run just a normal serial query. Basically, we're literally out of the hands-on lab, our live labs, in-memory fundamentals lab. These same queries are right there that you can try on the cloud. And I have some links, and we've talked about, again, the live labs version for database and memory of the in-memory fundamentals to go through database and memory. So you can actually try that on your own. But we'll run this query, and it's just our getting the max total order price from the line order table. That's going to do a full table scan. We see table access in memory full. And what I wanted to highlight, and I have all sorts of statistics, but we only really care about IM scan rows. Notice it's about half of the total rows. So and the reason for that is because since we ran a serial query, we accessed about the data that was in the column store on this node, and the rest of the data we had to get from the row store. So if we actually run that query then with parallel query enabled, which is what you would do, originally we required auto DOP to be enabled, and we relaxed that where we said you just have to make sure you have a DOP at least as large as the number of nodes. That's the rack part. And there are some, we've done some AskTOM sessions on rack, and there's some blog posts on rack as well to help explain that. And it's documented in the documentation if you want to read it there. But if we now run how we would normally run with distribution, a parallel query, and notice I've set parallel degree policy auto, and it runs a little bit faster. It runs fast because all the data is cached even in the row store. But now what we'll see is a parallel query run. And in the statistics, then notice you will get a note that says parallel scans affinitized for in-memory. So we know we've actually taken advantage of accessing that data across both column stores with parallel query. And now we'll see that our scan rows is jumped up. So we're basically at the same number of rows we've accessed from both column stores as the total number of rows that we've accessed. So that's those are kind of the checks on how you can determine that you have indeed accessed all of the data in memory. Because the optimizer thinks at parse time it's going to access that data, but if you've defeated the ability to use parallelism, then that may not occur. And so statistics are your friend here. Again, we talked about that as well. So, great. Now let's go to the case where we have, I'm just going to do, go ahead and copy and paste. If I can see what I was doing. two commands. I'm going to alter the table to be no in memory. Then I'm going to alter to be duplicate all. So I don't have to type, which is nice. So both commands, the alter table, we've taken line order and said no in memory. We have to take it out of memory to then repopulate it with duplicate all. And then we're going to alter the table, line order, priority high, duplicate all. So we should get it populated, but let's just make sure. We'll force a population if it hasn't already. Whoops, sorry. I can't even cut and paste properly. Just to make sure, and then let's double check. And notice that the duplicate all is now set. And notice also that the in-memory size is the same on both. So now we've gone from being distributed, so part of the data being populated on one node and part being populated on the other node. So we've now gone to where we have the total amount of data populated on both nodes. So now we really actually don't even need parallel query, but if one of the nodes were to go down, then all of the data will still be in the other node. Now, granted, this is just a two-node rack. So in essence, duplicate and duplicate all do the same thing in a two-node rack because we're going to duplicate the data. We only have two nodes. But in 4 nodes or 3 or more nodes, then duplicate and duplicate all will do something different because remember, with duplicate, we're just mirroring the IMCUs as opposed to duplicate all, which says we're duplicating across all available column stores. So now we have our data fully populated in both nodes for the line order table. So now when we run our, query, just our serial query, cross our fingers. We've run the same queries in serial. This reconnects every time we run a query, so notice the connected. So we don't have our auto DOP set. I don't have it set in the system, so we're going to do a serial query. We can verify that from the execution plan we see here. But now notice that our IM scan rows is still all of the rows that we've gotten from the table, basically. And so there's several advantages to that. One, if a node were to go down, you have your fault tolerance. 2, if you, for whatever reason, don't want to be using parallel query, and there are folks who, in applications as well, that either don't allow parallelism, which is not necessarily a good thing because parallelism can significantly speed up your queries, or don't allow inter-instance parallelism. In other words, they allow parallelism within a single node, but they don't allow parallelism to go across nodes. EBS is a great example of that. And we do actually have a white paper that kind of goes through a strategy of how to handle that. But if you have Exadata or an engineered system and can do duplicate all for those objects, then you can actually get around having to do things like subset column stores with the for service clause that's available with database and memory. So you can actually, it gives you more flexibility. And then the other thing to think about here is what if the line order table, which is our, so I have, now we're going to go off script just a little bit. I have a few more tables than just SSB, but in the SSB schema, the line order table is the fact table, so that's the large table. And my date dimension, part, customer, and supplier tables are the dimension tables, and they're much smaller because they're dimension tables. So if line order was partitioned, for instance, perhaps you have a data warehouse environment, or even in a mixed workload environment, you might have partitioning, and you have fairly large fact type tables that you've partitioned, and perhaps you only want to keep the most current partitions in the column store, and your historical partitions or your data that spans maybe a longer period, maybe the previous year, previous months, whatever your time frame is for your environment. Perhaps you only populate the most current subset of data for the line order table or your tables based on it being partitioned into the column store. If you then populate your dimension tables with duplicate all, joining that data to your partitions that are in memory can then occur all within the same local node. And so that can be a performance benefit rather than having to invoke parallel query to transfer resulting data, because again, we don't ship IMCs across the interconnected rack, but we're having to get data for these individual dimension tables that they're distributed across the rack nodes back to the invoking query where the line order partition that you're querying or joining against is located, can be a performance benefit. And it can allow you to avoid having to use parallel query, especially if you're in a mixed workload environment. Very often DBAs and architects aren't comfortable with having parallelism enabled in mixed workload environments because of managing the resources, although Resource Manager and other parameters that are available in the database can help deal with that. But bottom line is it gives you more flexibility. And to be honest, that's kind of what I wanted to cover for the topic. Is there anything else, Jesse, you can think of to point out that I didn't cover or maybe you want to elaborate on?
I don't think so.
Okay. So we've gone over the node duplicate example I have in here, and I'll post these slides, but I guess they're going to be now recorded, so there won't be a big deal. But I have our duplicate example, duplicate all, and then I kind of went through the same queries with the results here. So if I went through that too fast, or you don't want to go through the again, you can go through and see how I did this. And the reason I'm clicking through those is because I really wanted to get to, since we don't have any questions yet, but again, please feel free to ask any questions. Our resources page, so we have our blog, which is blogs.oracle.com/memory. And I did post a blog post about duplicate as well. And then our resources page, which you can go to, you can navigate through it, the main blog page, or you can just go directly to it. And we have links to both documentation, white paper or technical briefs, SQL scripts and examples, the link to the live labs, link to the in-memory fundamentals. If you want to actually run a database in memory and experiment with this. On live labs, I don't think you can actually use duplicate because I don't think it runs on Exadata. But you can certainly try out database in memory and some of those features. And in addition to that, I just have some links here that kind of highlight what I think are the most important ones. The blog, which I just showed you, oracle.com. We have a database in memory page. We have our own YouTube channel, which has some shorter videos on how to get started with database in memory. Our AskTOM Office Hours, which you've already kind of seen because the landing page there, if you go down below on that page, has more information available. And then don't forget the documentation. And as I mentioned, the 21C documentation is out and available. So you can actually go take a look at some of the new features. We do have several new features with database in memory coming in 21C. Because 21C is currently out in the cloud and will eventually be available in other environments as well. And so with that, that's kind of what I had. Again, if you have any questions, please don't hesitate to type them into the chat. And we'll kind of hang out here for a few minutes to see if you guys come up with some questions. All right, well, I don't see any questions, and so hopefully that was informative for folks that, again, are on Exadata, being able to use both duplicate, where we're mirroring IMCUs, and duplicate all, where we can basically populate each of the IMCUs for objects across all of the nodes. And if you do think of questions later, more than happy to, I got my email at my email at the beginning of the session. If you go back and look at this is recorded, I'll post the recording. You can certainly ping me on email or even through Twitter, and be more than happy to answer any questions you might have with this. And with that, thank you, Jesse, for joining me. We didn't have any stumpers for you.
No.
It's kind of nice to be able to have actual developers join with this, and we talk about some of these technical features to be able to answer questions. And with that, I guess we'll say goodbye.